Good morning, students. Today we shall discuss about the slope of a line, an important topic in coordinate geometry. So, coordinate geometry, we will start with our xy coordinates, and now we have a line like this. So, in coordinate geometry, there is a slope to every line in relation to the x-axis. This is what we are talking about. What is x-axis? What is origin? That can be anything, whatever you want to take it. And that origin can be shifted also. From the bus stand of your town, you can take the railway station of your town as the origin. That depends on what you are going to do and why you want to make this study. And shifting of the origin we shall discuss later on. First we shall take any origin. We have taken some origin, and basing on that origin we had planned an x-axis and a y-axis. Now every line you draw will have an angle with the x-axis. That angle is called the slope of the x-axis. So this has an angle, and we are talking about this angle, angle A. Of course, this has another angle here also. But for the time being, we are not talking about that. We are talking about this angle, which is the rotation of the x-axis. Normally, we discuss about this angle. Now, you see, this is another line. This line is parallel to x-axis. That means the angle of this line is 0 degrees because it is parallel to x-axis. Then we can draw another line like this. This line is parallel to y-axis. So the angle of this line in relation to y-axis is 0, but in relation to x-axis, which is what we take normally, is indefinite. 90 degrees, but that 90 degrees, the slope of that 90 degrees is indefinite. It's going like this. Why it is indefinite, we will discuss later on. Then we'll come back to our previous concept. There is a line like this. We have discussed before by drawing another line parallel to the y-axis and said this is the right angle triangle. Now we are discussing this. Suppose there are two points here. Meeting them became a line. Joining them together became a line. And so this line has a slope. This slope will get reduced if it moves towards the x-axis, and this slope increases if it moves towards y-axis. In the previous classes, we discussed that x is cos theta, y is sin theta. We discussed about triples. We discussed that sin A is equal to x, sorry, y cos A is equal to x, and one more thing we discussed before, tan A tangent is equal to y by x. Tangent tan A is equal to y by x. These are the basic ratios of trigonometry, and these basic ratios, their reciprocals become 3 more and total 6. So now we are talking about this particular ratio tan A. The slope of this line is nothing but the tan A, nothing but the tangent. So trigonometry and coordinate geometry I am integrating. They are not two different things. The same thing which I discussed in trigonometry, I am now extending them in coordinate. Not some other thing, no new formulas. We don't have any formulas, we have only one. Now see, tan A is equal to y by x. In coordinate geometry, in a separate lecture, I will tell you the how the line is represented algebraically. For now, we say that this is mx, y is equal to mx, m times x. To simply tell, this may represent the speed of a car. Time, which is an independent variable, is usually represented on the x-axis, and the position of the car is usually represented on the y-axis. The position of the car is dependent on time, and these are the hours, whatever it is. Time is not dependent on others. Time is independent in our general, in all our general discussions, time is independent. The position of the car is dependent on time. If the car is moving, the position changes. If the car is not moving, even if time changes, the position will be the same. So, take this line as representing the movement of a car. Suppose another car is represented like this. That means this car is moving slower when compared to this car. I take another car and do a graph like this. This car is moving faster than these two cars. So, what is speed? Speed is nothing but the slope, which is nothing but tangent, which is nothing but differentiation in calculus that we will come later. So, for now, we have discussed two important concepts. One is the tangent in coordinate geometry, in trigonometry, and the other is slope in coordinate geometry, and we are going to both as a express. So now, what is the slope? You see, from this y is equal to mx, m is the slope, m is equal to y by x is equal to tan A, both are same. So now, let us come to the coordinate geometry proper and take only one line with the 2 points. Even the complete line will not be given in coordinate geometry. Line is the shortest distance between 2 points. That is how we define a line. So now we have 2 points with xy coordinates, and this is the line we are talking about. So take this as P1 and this as P2. Now we write triples. P1 has some triple like 5, 12, and the third one will be 13, not required. And P2, take it as 7, 24, and the third one will be 25, not required. Now from this data, I now write the line triple. P1, P2 is the line. This is 5 minus 7 is minus 2, 12 minus 24 is minus 12. And the third one, I will calculate by Pythagoras. But that's also not required now. Now what I require is the slope of this line. Slope of this line is y by x, tangent. So y by x is equal to r, slope is equal to m is equal to minus 12 by minus 2 is equal to 6. Finished, I got the answer. Any line which is represented by 2 points, if the x and y coordinates of the 2 points are given, write the triple, then write the triple for the line. This is x, this is y, you know, so y by x is the slope of the line. Finished, we got it. Nothing more than that. Then, suppose we had two lines. We had two lines or 3 points. And we are asked to find out whether these two lines, this line and this line, are collinear, or 3 points are collinear or not. How do you find out? Yesterday, in the previous class, we discussed one way. That is, find out the length of AB, length of BC, and the length of AC. If the length of AC is exactly equal to the sum of length of AB plus BC, then it is a collinear straight line. Now we do it in another way. Any straight line should have the same slope anywhere you take. Anywhere you take, it will be having the same slope. So calculate the slope of these 2 points and calculate the slope of these 2 points. Then they are collinear. Actually, they are parallel. I tell you one more. Suppose we have two lines like this. Both have the same slope. You calculated the slope for the two lines. Both have the same slope. That means they are parallel. But here, in the previous example, whether they are collinear or not, for that they should have a common point. These two lines should have a common point. Not only they are parallel, but they also should have a common point. Then they are collinear. If only they have the same slope, but they do not have the common point, then they are only parallel lines and not collinear. Then, to do another example, suppose we are given two lines and we want to find out whether these two lines are perpendicular or not. These two lines are perpendicular or not. In that case, what happens? Find out the slope of the first line by the method we have just discussed. It is nothing but the tangent. And then find out the slope of this line also. And you will find a very curious relationship that the slope of the first line m1 will be equal to minus 1 by m2. This line is m1, this line is m2. The slope of this line. The slope of the first line m1 will be equal to the negative reciprocal of the second line. If this relationship holds true, then these two lines are perpendicular to one another. So, find out the tangents, find out the ratios, write the triple. Y by x, you got the slope for this line, you got the slope for this line. And if it is, suppose the slope for this line is 2, m1 is equal to 2, and m2 is equal to minus 1 by 2, then these two lines are parallel. Finish. Our subject is finished, we go for examples.